Hi, we are going to be talking about vector fields. To get us going, the velocity and force of vector fields. Vector field is a function that assigns a vector to each point in the plane or in 3 space. Like we kind of already talked about, I think this past Tuesday, we're going to be having some point, and then we're going to have a trajectory for that point. Now, the magnitude of the vector will actually create a longer vector. So we'll see that in just a moment here. But here are just some examples. So here we have the velocity vector field for a Gulf Stream, and then the gravitational field for Earth, right? Because everything is pulling in towards the core there. So these are just visual representations of what it just looks like. All right, so here's our definition for a vector field. Again, in 2 space is a function, but notice there's a vector symbol above the f. So we're creating some vector of the function whose value at the point x comma y is a 2-dimensional vector. Similarly, it's the same thing for 3. Key things you want to note here. So if we're looking at this this example 2 here. Notice here it has x in the j direction. So we're going to be doing everything vertically here. So notice if I plug in negative x's, well, I'm going to be getting a negative number, which would correspond with going down. But notice also too, even on the positive side, just looking at figure 17.22, notice that if we look at this first column here of arrows is smaller, and then we go to the second one. Let's say this is a 2, like 2j. Here it's getting a little bit longer. Oh, 3 going even bigger, right? So the bigger the absolute value of the number, you're going to get longer and longer vectors there. Same thing going on for figure 17.23 here on my right. Notice that this is going in the I direction, which would be horizontally. So if you plug in positive numbers, it's going away from the y-axis, right? Same thing for the negative direction as well. Okay, so looking here at the gradient vector fields, so here we have some contour lines. Now, here's the thing when it comes to vector fields, in terms of the gradient vector fields to a contour line, is the arrows move in the direction of the incline. So I'm going to show you what those look like in just a sec. But if we look here at figure 17.26, well, if you picture it, right, you should have some type of upside down dome kind of looking thing, right? Because we have 1 in the center and then it goes outward, right? So when we're thinking about what the vector field is going to look like, the arrows are going to be coming away from the center, right? And then we look here at figure 17.27. Is coming from -3, -1, 1 to 3, right? So is for this one, figure 17.27 is going to converge in on the center or 0, of the plane. And then if we look here for the figure 17.28, notice how it's going from -3 to 1 to 5 to 9. So all of these should be uniformly going towards the quadrant 1, if you will. So we look here on my next slide. Kind of like what we were just talking about, since for figure 17.29 here, it is moving outward, so the vector arrow should be moving outward as well. Here for the next figure to the right of it, they should all be converging in, and just like what I was mentioning for the last one, they should all be moving uniformly to the quadrant 1 positively. Good. Now let's look at some example problems here. So we're looking here, and it says choose the correct formula for the vector field. Now, all these are going vertically, so we can dismiss any of them that have I. So the second one, gone. This one, gone as well. This one, gone as well. And I'll just leave these two. But also kind of, let's think about it. So we already seen a case for this one, right? If I'm plugging in positive values, then they're all should be going upward this way. And then if I'm plugging in negative values, it should be going down. Now, if we look at this one, well, if I plug in a negative value, I'm going to get a positive number. So that makes sense for all the y's that are below the x-axis to be going towards the x-axis, because you plug in a negative number for the negative y here, you're going to get a positive. So it's going to be increasing to x. And just like if I plug in any positive number above the x-axis, then I should be getting a negative number that will make it converge to the x-axis here. So that is why this one is correct. Let's look at another one. Okay, so looking here again, since everything is kind of converging too, right? This one should look very familiar to the one we were just looking at in the slides, that middle one here. Notice that since they're all kind of converging in, well, we can definitely get rid of this guy here. No, don't need him, because this would just only signify that it is going in one direction. Now, if we look at the bottom one right below it, now notice if I put in a negative number, then they should be pulling away from the center, right? So since that is not the case, we can take that one out. Now, if we look at this one, again, if I'm plugging in negative numbers, this would be converging away. So that one's no good. And then same thing here. If I plug in negative numbers for the y, they should also be converging away, but that's not happening here, right? This one will be the only one that will cause me to converge in. Reason being is if I plug in a negative x value, and if I plug in a negative y value, so anything over here, it should be converging in to the x-axis, which it is. So that is why this top one is good to go. And let's look at one more. Okay, so here is just like that last slide, so that I was just showing you guys. So if we look here, again, it goes towards the incline. So here is going from negative 0.5 to 1, same thing on the other side. So everything should be converging to this line here for 1. So that would give me this guy. And we can kind of tell, right? You see how everything is converging in to where it would be 1 right here. Now, if we look at the next one, well, things are getting bigger as you pull away. So that will be this one, right? Notice how the arrows are pulling away from what would be the -1 line right here. And here it looks like everything is just increasing to this top right corner here. So that's why we want this one, right? Notice how all the arrows are uniformly going to this top right corner. That's why this one matches with this one. And if we look here, notice how everything just kind of is going towards that bottom left corner. So we want all the arrows uniformly going to the bottom left, which would be this guy right here. And yeah, that would do it for vector fields.